we'll briefly discuss what sorts of use cases across different industries and verticals that we have enabled in our short journey thus far. And then as a company, we'll just talk about briefly how we work. This will be introduction about ourselves. Then I'll talk about one example in the context of how one can build an end-to-end data app to run operations related to inventory in a large retail organization, where an app that may be used by many different personas. I'll give you a little bit of flavor of that. And again, we want to be able to build that in an hour here. So instead, what we'll do is that we'll take a miniature version of that, and that will be our hands-on component. And I will walk you through each step of building as we go through. Through the process, our hope is that some of you will be able to follow along, but you will have enough material for yourself so that if you can't follow along, that's fine. You can just simply think of this session as a learning, and then later you can go back and then build it at your leisure. So with that, the first and foremost, if you register for this program with email that you registered, you must have an account has been created for you. For that account, Chanakya would type in the chat of the thing, what is your password? So, and I will sort of tell you in a second an instruction of how to go and log in. So let's start with the logistics first. Okay. So highest level, this is your onboarding guy. Okay. So let me make sure that sort of Chanakya, if you could make sure that sort of this link is available in chat so that people can follow along. Once you will go through this instruction sheet, as you will see, there are a variety of basic sets of instruction. In particular, first and foremost, you want to log in into the portal. To log in into the portal, you have to use your email that you use to register for the email. And there's a standard password for that. So don't share your email because your email is your password in this case. Of course, then later you can change your password. This will give you the access to Ikigailabs' trial portal for some time. There will be online support available at community.ikigailabs.io. It's a Discord community. Please sign in there. We'll be always providing live support there through this session and beyond. The hands-on component is going to be a majority of today's session, as I said. And again, follow along if you can, but don't stress about it if you're lagging, because all the instructions you need for building will be available for you within the platform. And I will show you. Basically, once you log in, all the information you need is there. Finally, at any point of time you want to get in touch with us, please send us a note at cs@ikigailabs.io. So with that, let's get a little bit into the details. Okay, so again, as Vinay mentioned, I'm co-founder and CTO. I started a company with Vinayak Ramesh. Vinayak is the CEO and co-founder of the company. He was previously co-founded Wellframe, where he was a CTO. Wellframe was recently acquired by HealthAge Blackstone. He's an undergrad from MIT in 2010, 2011, out of which he started Wellframe. After Wellframe, he came back to MIT, where he was one of my former graduate students. And that's where we connected on the mission of Ikigai. And then the next question was that how do we make it happen? And that was a serious tech problem. And that's where sort of his thesis was developed. And once we were ready, we decided to spin out the tech out of MIT, and here we are. We have a terrific group of former industry veterans, founders, folks in data space, and investors supporting us. So really excited about that. Getting into the weeds, our mission is to help build self-driving organizations. Now, you must have heard of things like self-driving cars. And in a sense, self-driving car is a great mission for modern AI, which has driven a lot of development in robotics. Now, if you think about building self-driving organization, a natural reaction would be that, hey, we're going to let's replace all the humans and replace them by bots. It's exactly the wrong thing. In a sense, as you may all agree, at the highest level, our folks, if you are connecting, and please mute yourself. Thank you. We are hoping that the session will be interactive, so that we have not hosted this as a webinar style, but this style, but also with that, also responsibility comes with everyone. So please be mindful of keeping yourself muted unless there is needed. And if you want to speak, feel free to just raise your hand, and we'll, of course, you should be able to get an opportunity to speak. All right, so back to as I was mentioning, on one hand, one naive view of building self-driving organization is replace humans by bots. That's not what we agree with. That's not what we believe at all. In a sense, what we believe is organizations are built by people. Of course, organization is a mission, and mission has to be important. But more importantly, a mission becomes successful or not because of the people who are within the organization, the people who define that. So self-driving organization does not mean replacing those important people. Really, self-driving organization means that helping, augmenting people within the organization, and especially our goal is to do that augmentation using data. Okay? Some of the most amazing things that have happened towards that is things like spreadsheet. And our hope is that we can help people do anything you can do with AI using data if you can use spreadsheet. Okay? And at the end of the day, what Ikigai has built is an operational platform, operational BI platform that enables anyone to turn data into actions. So now it's likely that you already heard about this keyword. So how are we different? What is it that we are doing? So just to put that into a little bit more context, here is how we think about it. So at the highest level, the goal of any reasonable data-driven BI platform is to help organizations collectively make decisions to achieve better return on investment. In a sense, a natural way to think about an organization is, or any business, is some form of financial instrument. Okay, a financial instrument, you put in some money and you hope that you're getting returns that are better than what you can get in public market. You're running a retail organization. In an operation cost of the retail organization, you're investing $100 on average a day, okay, over an entire year. Well, if you are making $2 every month on those $100 investment, your return on investment is effectively 24%. On the other hand, if you're making $2 at the end of the year, your return on investment is 2%, in which case maybe it's better that you stop the business and invest into S&P. So that's the view, one way to view a business. Okay? And to enable such decision in a meaningful manner, and just to compute what your return on investment is, you want to use data. And typically, these are the 6 steps of data-driven actions that take place. First and foremost, somehow collecting data. This data maybe now in modern times live in environment like Snowflake. Things like Databricks and Fivetran, depending on the environment, help you build scalable or easy connectors to those environments. The next step is using this connected data to prepare that so that you can do something on top of it. This is where things like Alteryx, tool like Alteryx come around and help you. If you want to build advanced analytics, maybe you can just use your Python skill, your R skill, or other ML specific tool sets, and you take the help of the vendors to build specific point solutions. You want to visualize these things, you use visualization BI tools like Tableau, Power BI. You want to sort of solve a point solution, you do things like Anaplan, and if nothing else, spreadsheet. And finally, you want to put these into action, you use do some automation, point-to-point automation, use UiPath. As you can see, to do this thing holistically, end-to-end at scale, you need different persona within your team, different tools, and all that. What we at Ikigai decided to do is to build all of these together in one place and enable all of them through a simple spreadsheet-like interface, but also allow you to have ability either to have small-scale uses such as those supported by Tableau and Power BI, or large-scale uses such as those supported by Databricks. So in a sense, while interface that you will see today, and as some of you are already logging in and started playing with, it's deceptively simple. And that is the point. Okay, just to give you a little bit about the tech that enables behind the scene. And again, none of these should be visible to you as you use the platform, because it's supposed to be behind the scene. But at the highest level, as a user, you will find yourself doing most of the things in no-code manner. It is a cloud native. It enables scale both in terms of data and compute. It enables various sorts of automation. Visualization actually allows you to build an end-to-end data app. Typically, if you have to sort of, let's say, set up a small company and you want to build a nice, simple SaaS app, you would have to acquire resources on any cloud environment, do enough DevOps, put up web server, put up a front face, put up sort of a backend, and then everything happens. With Ikigai, you can do that entire thing end-to-end with drag and drop, and a simple version of that SaaS app we will build today. Okay. Things like automated scheduling, connectors to all sorts of things, like say, if you want to connect to Salesforce, SAP, whatever, you can just simply connect it by clicking. And if time permits, I'll walk you through one simple example of how you can connect to Salesforce within 2 minutes. Okay, and all of these underneath is driven by our patented tech, some related to that enables AutoML, some enables stitching data at scale, and some sort of is about how do you architect all of these things so that the user interface looks simple, but behind the scene it scales really. Okay. All right, so with that, just to give you a few examples where we worked successfully. These are just a few examples of applications that have been enabled by us for our some of the enterprise customers across verticals in retail, finance, healthcare, and manufacturing. And this is this type of use cases that we have found that Ikigai enables particularly well. Okay. Typically, we work in many different flavors. On one hand, you can simply get access to the platform that you are getting it right now, but at scale. So that's access to platform, and you can go ahead and do things. And of course, we provide support the way we provide support today. Or if you want additional support, such as helping with thinking through the point solutioning, we provide that support as well, either through education or helping you build a solution end to end, or all of the above. Okay, so if any of these would be interested at the end of the session, please feel free to reach out to us. All right, so enough of talking, and now let's get into some example. Okay, so I mentioned that we can enable a variety of use cases. Let's focus on one simple application of inventory optimization. Okay? And here the key question in retail is how do you decide how much inventory to order every day? Okay, should you order or not? And if you order, how much? So imagine you are, just to keep things super simple, imagine you are somebody who is running a shop where you're selling shoes. Okay? And all you're doing is just selling shoes. And all you want to make sure is that on one hand, you don't have too many shoes in your back room, that you invested too much money into it. On the other hand, you don't want too few shoes so that if a new customer comes in, she or he doesn't find a shoe that she's looking for. Okay, so it's about balancing, not too little or not too much inventory. Okay, one way to do that is every day check how many shoes are there, based on what thing you're looking at, based on what historically you have seen, you will decide whether to order or not. Okay, and the goal is to, at the end of the day, maximize return on investment. But maybe you want to increase the revenue, or maybe you want to keep investment only so much and see how best you can still get revenue. So there's a whole trade-off curves. So how does one decide this? And once make a decision, how do you put it into operation within clicks? This is something that I'll show you with Ikigai in a second. So with that, I'm going to sort of switch my screens now. And then this is where you will see the first view of Ikigai platform. So 1 second. There we go. And Chanakya, I presume if you say yes on your screen that you see my screen change. Thank you. All right, absolutely. So here is an end-to-end dashboard that I built in Ikigai to enable this simple question. Okay. Now it's a very busy dashboard. So let me sort of slowly parse it for you. Okay. Let's see if there's a question from somebody. Okay. So this is a busy dashboard. So let me parse it for you. Okay. First and foremost, let's focus on this part. Okay. So what is this part? This is so this one is what we called a process diagram. What is it doing? It's basically saying that, look, the process of going from data to decision in this app goes into 6 steps. First is connecting to data, then using that data to produce some derived data. Okay, doing a little bit of analytics on top of it. That is more like a rear view mirror view rather than a front view mirror. Then actually a front view mirror doing some advanced analytics, forecasting. And then looking at careful policy decision of how do you sort of make a day-to-day decision using data with the end goal of making the most on your return on investment over year, over duration of season, and so on. Okay. And what this does is this effectively digitizes the processes that you have in an organization, so that even though different individuals may work in different verticals of this app, at the end of the day, collective organizational process is fully digitized. Okay. There are a few basic metrics that you might want to keep track of all the time. Okay. Things you might want to filter as you view things, and so on and so forth. Now, what I have here is these basic processes converted into operations. Okay. Things like connecting to live data, inventory tracking, sales forecasting, and all that. I'm not going to go through all of those things in interest of time, But let me just focus on one of the things that we will produce at the end of it. Okay. So here's a nice policy chart. What this shows on x-axis is amount of opportunity that was lost in last season. So higher the number on this, bad it is for you. Okay. On y-axis, I'm showing on average how much amount of money that was invested in your inventory. Okay. Higher the money, which means that you are investing a lot more dollars into your business. So really ideal would be you want to stay here. You want to invest as little as possible, and you want to lose as little opportunity as possible. Okay. Of course, the reason you miss opportunity is you're not keeping enough inventory. Okay. If you're keeping too much inventory, that's what is driving this high. So really, you want to not keep too much inventory, and you don't want to lose any opportunity, and that's why this is a great place to be. Okay. So now, using historical data, what we in this chart, what has been done is it shows that, well, looks like given the data, on average, 900,000 or so opportunity was missed over last season using whatever policy was in play. And how do you generate this? Well, you have historical data. You look at the times when you were out of the inventory. And when you were out of inventory, you can forecast or impute the demand. And that's where the demand forecasting piece comes in. But once you do that, then can help you tell you how much opportunity you missed. And as you did this in the last season, you were investing close to 116,000 on average per day. Okay. Now, it turns out, looking at historical data, there are some other policies that allow you to actually keep roughly the same amount of money invested, a little less actually. And instead of losing 900,000, you're losing opportunity of close to 600,000, which means you made 300,000 more without changing any inventory investment, but just by being clever about how you use your money. Okay. Or if you want to increase your revenue even more, maybe you can double the investment in your inventory, which is what you're doing here. And now instead of losing 900, you're losing only 250, which means you made close to 650 more by investing 100K more. And question is that worth it for you or not? That's a question only you can answer, not a machine. But now you have an options. Now you can ask questions. So what do each of these bubble look like? Right? Each of these bubble looks like a policy recommendation of something like that. And this is a busy chart. So let me quickly parse it for you. What it says is that for this queue, whenever certain number of days of inventory is left, you order certain more number of inventory, okay? And then that's how you're making a decision. So again, in the example of shoe that I was telling you, if you have in your store 10 or less shoes left, what you do is you order 40 shoes. And now 40, where is it coming from? 40 is coming from expected or demand that you have for next 10 days. Okay. And 11 says that it's a demand that's going to last only for 2 days. So really, that's again where a good accurate forecasting comes in, along with the policy generation. Once you have this policy, you make a decision based on your current credit line and whatnot, that these are the things I want to order. Let's say you save the changes and so on. Ordering suggestions are created. You press a button, goes it downstream into your SAP or whatever system you're using, and then the order is sent out. Okay, and this is how this type of human in the loop data app has helped you make decision in a meaningful manner. All right, so I would say enough about an example context. Let's get to today's building, what we're going to do today. And with that, let me switch my slides back again. Okay, so Okay, so today's hands-on components. So what are we going to do today? Here's what we're going to do. We're going to, today's task is to predict prices of house and build a data app that allows you to ask query for any house attributes and it'll produce a new recommendation. So it's not just prediction and you sort of do cross-validation. This is actually an interactive data app, which means that you are actually doing all the MLOps, as people call it, and putting it behind the scene and actually building the whole end-to-end app. So let's see what that means. But in the process, we'll take the data, build predictions with drag and drop, interpret the prediction, and then sort of put it into the operations. Okay. So we're going to start building. There are a few instructions that sort of I want you to remember as we go through it again. Remember that sort of you're having right now an access in a trial cluster of Ikigai. If you need more access, for example, for a good reason, provide us some feedback, share your reviews with us. If you have built some of the hands-on components, share with us that as well. Build something new and share with us. And each of this might get you a few more sort of weeks of access. And some of those who would sort of, who have participated and done something with your today's session will also send you a participation certification near the end. So please be on the lookout. All right, so with that, let's get started with the hands-on component. Okay. All right, so this is the style of dashboard again that we're going to build. And again, I've not given you an overview of the product yet, but I will give you at the end. Okay. In this project, we're going to do something simpler process. We're going to look at a housing data that has two types of data sets. One is features of houses and prices. So let's see how it looks like. So these are different features of the houses. It's a different row of the data set. This is something called CRIM, different zoning, industry, chaos, all of that. The key one that we are going to focus on is three features: LSTAT, that is percentage of lower status population in that region, number of rooms. Okay.
Safe to say, all
right, I think we can hear you, Tarun and Ayush. Okay, thanks. All right, so number of rooms and the age. And what age says is that proportion of unit that have been built before 1940. So age is a number which is between 0 and 100. Higher the number it is, older houses that place has. And okay, room, of course, number of rooms, more rooms it is, more rooms you have in the house. And LSTAT is a percentage of population, again, it is between 0 to 100. If the percentage is large, which means that it's primarily occupied by folks with lower income. If its percentage is smaller, it's primarily occupied by higher income. Okay. And at this stage, what we're trying to do is trying to predict for that region the median house price. Okay. And again, these are normalized price, so there'll be a bunch of zeros that will be missing. We're trying to sort of predict the median house price. And at this stage, you might say, well, you know what? It should be that lower stat should be predictive completely, or room should be predictive completely, or age should be predictive completely, right? So to understand that, let's do the following. First, we'll stitch the data because the prices and features are separate. So first, let's bring them together. It's a very simple stitching problem, but I think it just gives you a flavor of how does one go about stitching and doing basic data prep. After that, we'll analyze it and see sort of how price versus these features behave. And let's see how easy or how difficult the prediction problem is. After that, we will build some prediction problem. We'll build a sort of a real recommender and then we will do the MLOps, again, what we call MLOps in popular jargon, but it will happen behind the scene, and build the end-to-end data app. And I'll show you the app you're going to build. Okay, so let's just sort of look at what the stitch data looks like. So all that has happened is that I've put those two data sources together. So now features of that region along with the median price value is also on one place. Now, there is some description that we have, and this is just a basic summary of statistics of data. But here is the most interesting chart. Okay, what I have here on y-axis is the median price of house, and on x-axis is the percentage age. So remember, higher the number, many older houses you have, and you might have expected that maybe older houses price should go down, which means that it should decay. But this is just a nice skyline. It just keeps going up and down. There's no information as such alone in age. Okay, so it's not a straightforward thing. If you try to plot something, the same thing, maybe there's a nice exercise for you to extend on this dashboard is to the median average age, median price versus number of rooms, or median price versus the LSTAT, and you will find a similar skyline. No information, individual. Okay, this is really sort of a not so straightforward problem. It's a deceptively simple but really hard problem. What we will do is we will build a predictive model within clicks, so that despite the fact that the price or median prices with, for example, LSTAT or with room not having any information because it changes in no specific visual trend, for each of them, this is the real values and these are our predicted values. And as you can see, those are two very close, which means that we are doing really, really well in terms of our prediction. So now that whatever we've built, you will have some confidence, both visually and in numbers, that our predictions are good. Let's go ahead and build a predictor recommender. So here is a simple, not pretty, but functional, amazing app. So what does this app do? All right, let's see. Suppose I'm going to sort of add one more thing to this. Okay, so 30, 10, and 4. So what I want to do is there is this 3 different queries, okay? 3 different houses or 3 different regions. One region, average 20% of the population is 1940 or before. Lower income status is 20%, and number of rooms on average is 10, and so on. So these are 3 different queries. For these queries, what I want to do is I want to run recommendation. In particular, the prediction model that you saw behind the scene that I built. What that prediction model effectively does is it takes any such input and it can produce a prediction of housing price, a housing price which would be the median price that we're trying to predict. And what we want to understand is what are the sort of the predictions that will be made by our model. And here are those predictions that are made. So for example, remember this is the new entry we had added, which is here. It says that sort of the price would be this. Okay. And this is a real interactive data app now. There is ML ops model that the model you built, now you can query it in real time for all sorts of purposes. And again, here we're just showing something simple, but you can sort of build something like more complicated stuff like this. More complicated stuff like that inventory app that I was showing. Okay, so with that, we're going to sort of start now working towards how to build this kind of a dashboard from scratch. That's going to be the goal. Okay, so first and foremost, what's going to happen is that you would have in your environment. So I have lots of projects, but in your environment, you would have logged in, see some projects, look for a project called Start Here. Okay, this is my Start Here project. In that Start Here project, or any project for that matter, you have a bunch of components like this. Okay? So data set, connectors, and database, these are your data resources. Okay? You can upload data or bring from somewhere else. You can connect to different data sources like Salesforce and all those third-party data sets. Or you can actually have build your own version of your local data store, like database. Okay, we're not going to deal with this today. But if you wanted to sort of build your own version of Snowflake, rather than going and paying a ton of money to Snowflake, if you want to sort of do it, you can just do it here. Okay, so all of that is that. Flows are your compute. Okay, anything you want to do with that data, and you can do here. You can do sort of prepare, stitch, analyze, visualize, and all of that. Dashboard is where sort of you build dashboard, whether it's sort of traditional dashboards like BI dashboard, interactive dashboards like what I was showing you. This is where you host your models to enable your MLOps, such as, for example, in the case when we were asking in our application question that for these housing features, tell me the price. Effectively, the model that's stored here was responding to it. And finally, resources. Resources is effectively any project, any task. There's always some information associated with that. Think of slides, think of content, anything. Here with this project, we've got a bunch of resources, and this will be the key. So if nothing else you remember from this meetup, this is one thing that I would like you to remember. I think, yeah, so if nothing else you remember, one thing that I would like you to remember from this is that go to the resources in your account access that you got received and walk through these things, and that's where the links for YouTube videos. So the end-to-end dashboard that we want to build was here. Okay. The first was inspecting data and then stitching data. So let's try to start with data stitching part. Okay. So here is what I'm going to show you is a step-by-step guide of data stitching process. I'm going to walk you through the video. If you click on this link, you would get a YouTube link, and then you can watch it. And I'm going to watch that with you now. And I'm going to walk you through these steps one by one over next hour or so. And hopefully by that time, you learned enough. And hopefully some of you are already following along in building this. Okay. So let's get started with that. Again, remember what your login credentials are. Remember that sort of to try to get help on community.ikigailabs.io help and follow along what I'm doing. And if you forget, you can't follow along, you could just sort of go back to your account, look for your Start Here project, go through resources and just sort of click on these links. And that way you can sort of rebuild again.
Sound is not coming.
I see. So sound is not visible or audible?
Yeah, it's not audible.
Okay, let me sort of do the following. Let me change it from my earpods, and that might make it visible. Can you still hear me?
Can you please reshare your screen with sound sharing option on?
Sorry?
Can you please reshare your screen with the sound sharing on?
Yeah, it should be on now. Give me a second. I see. Okay, so it asks me to do a little bit of restart. Give me 1 second, okay? Okay, all right. And can you see my screen?
What the different moving parts are and what our output is. So when we click on the data stitching flow, we see here that we have 2 imported data sets we're going to join these data sets into one data set. We're going to drop a column, and then we're going to have our exported data. So really quickly, let's take a look at first our housing prices. And we can do that by hovering over this arrow and clicking peak. So as you can see, here we have the row, sort of the identifier for the data point, and we have MEDV, which represents the median value of the house, of the neighborhood of the house. So this is represented in thousands of dollars, and as we can see, we have just a very simple data set for prices. Now we'll take a look at the housing features by clicking this peak, and we can see once again we have this row identifier, and we have all kinds of features here. So CRIM represents the crime rate, RM represents the number of rooms, age represents the number of homes built prior to a certain date. So these are all of our features, and as you can see, there's no price column in this data set, so that's why we want to merge these and stitch them together. So then we're going to join these two, and as you can see, if we edit the facet, we're going to join off of the row column, that identifier column, and once we do that, we can take a look at what the data looks like. So now we have our row, we have all of our features, and over here at the end we have that MEDV column, which represents the prices. Then we want to just drop the rows column now that, you know, we've already stitched the data. So we're going to drop that column, and once we drop that column, we no longer have the row column, we have all of these features, and we have the price. And that's going to be our output that ultimately gets exported to a data set. And that's a overview of what this first flow does. We simply take.
So what we saw here so far, right, is that there's a type of flow that will be built. Now you might ask question, okay, how did you get to that flow? What are the steps? And you're just given this. I just wanted to give you first overview of what would come. Now let's work towards this step by step. So let me sort of now go back to my again, my Ikigai project. Okay, so I will show you sort of how I would get to the next version. Okay, so remember, this was the this is the YouTube link that we were looking at, which was overview. Just to tell you what we're going to build. Now, this is what is a step-by-step guide. And again, in each of the pieces in the platform, you will see this is the structure. So just to show you, this is the first data stitching, then price prediction. Price prediction, there'll be overview and step-by-step. Then there's a recommender, overview, step-by-step. Then we will talk about dashboard design. There are a few bonus components. Like if you wanted to design an alert, for example, something changes or some such thing and you want to constantly monitor. Okay. In many of the operational tasks these days, we want to keep tracking the metrics. For example, you have you are running a business, and first order of thing you want to do is that, well, your revenues start going down. You want to understand if that is happening or not. Something else you're monitoring, if it's going up or down, you want to track that. You want to design an alert that sort of informs you via SMS, email, or whatnot. That type of alert design. And for these kind of alert design, if you're doing this in a data-driven manner based on what's published out there, let's say you want to sort of know that when S&P goes up or down by a certain amount, you can sort of do that, then connect to a website, scrape data from web and in real time do these things. Again, this will show you that. And then finally, if time will permit, I'll also show you if you wanted to connect to any sort of connectors, 160 plus connectors. Say example is your example of Salesforce connector. We'll see how you can sort of do it within 2 minutes. Okay. So these are the steps. Let me go back to the data stitch and walk you through step by step. And again, my hope is that maybe some of you are following, but most of you are not following as in terms of doing it right now, but hopefully some of you are simply going to sort of listen, learn what we have to do, and then sort of when you get a chance, you will do it. And Bharat, thank you for your nice writing on my screen. I'm going to sort of clear all the drawings. Okay. Right. So with that, let's do a step-by-step walkthrough.
I'm going to do a recreation of the data stitching flow from scratch. So let's take a look at this, if you don't remember from the last video, of what the data stitching flow does. We take in two imported data sets, we join them by an identifier, we drop a column, and we export our data set. So let's go back to flows, click the plus, and create a new flow. So the first thing we want to do is have our input data sets, and if we click on this data sets tab over here, we have housing prices and we have housing features. Now the next thing we wanted to do was join these data sets, so if you click on the plus add facet, we're going to process data, go over to merge and click join, and now we can drag from housing features and also attach that to join. And then once we join, we want to process column, drop columns here under DB operation. And then finally, we will output to an exported data set, like so. Now, there's still a couple of things we need to do. We need to specify a couple of arguments for these facets. The first being how we're going to join these two data sets and which column or columns we want to drop. So the first thing that we want to do is let's peek these prices and the features to make sure that they are what we expected. So prices looks good and features also look good. So now what we can do is if we hover over this arrow and hit edit arrow, we need to specify which side which data set is going to be on. So we'll specify, say we want the prices on the left and the features on the right. Now, once we click on this edit facet for join, and we will say left, and we can look at which column we want to join on. So we will do row for both of them. So you find row here, and let's update that. Now for the drop columns, we just want to drop that one column, which is going to be the row column, once they've already been joined. So we'll just click row and we'll update that right there. Now quickly, before we export, or I should say we should edit this facet first. So we'll do a CSV and we'll say stitching demo output, and we'll update that. And then to make sure that this flow is working, let's just peek right before the end. And this looks about right. We have the prices on the left since that's how we specified it. We have all of our features and we have no row column. So now let's run the flow and make sure that it works. And that ran. And let's make sure that we have a data set called stitching demo output. If we refresh, go back over to data sets, we have stitching demo output right here.
All right, so that was again just step one of data stitching, but step one of data stitching done step by step. Okay. Next, what I'm going to do is I'm going to move to the next stage. So again, we're going to go through four steps of process. So we're going to go through this slowly. I'm not going to rush through it. It may look like a very slow movie playing. if you're listening, but really this is very instructive, helps you sort of understand sort of how to do things. And now, next what we're going to do is we're going to do pricing, prediction. This is really sort of exciting because as you will see, instead of building a complicated machine learning model, you'll be able to build a complicated machine learning model, but just within clicks. So let's understand. So first, let's see what the overview is, and then let's do step by step.
I'm going to go over the price predictions flow, and we're going to do a high-level overview of how the flow works, what our inputs are, and what our outputs are. So if we go over here to the left, our input is the output from our previous flow, which is the stitched housing data. Now, if you don't remember what that looks like, let's take a look at it before we begin. We have our price here, represented by MEDV, or median value of houses in a given neighborhood. And then we have all of these different features which represent different characteristics of that neighborhood. So at a high level, what we want to do here is we have a lot of features in this data set. So first we want to select which features we want to look at, as well as our target column that we want to predict on. Then we're going to make 2 copies of the data, one of which we will use to predict. We'll predict the median value in this case, and then ultimately we will join that with our original data, and we will get an output where we can see the selected features, the actual median value, as well as our predictions. So let's quickly take a look and see how that's happening. In this, we use a select facet to select which target columns we want to look at. Now, of course, we want to select MEDV, our price column, as that's going to be our target column, and we need to keep that in our data frame. We're also going to select age, which represents the number of homes in the neighborhood built prior to 1940, RM, which represents the average number of rooms in the neighborhood, and LStat, which represents the percentage of the population that has a lower status. So once we select those columns, let's take a look at what our data looks like. We have our price column, and then we have these 3 features that we selected that we were going to use to predict our price column. So here in our predict facet, we have a random forest decision trees model, and we're going to use that and specify our target column to be MEDV, and then we are going to essentially make a new column for our prediction. Once again, we're going to specify that we want our original on the left, and then we'll append our prediction to the right. We'll join, and then we'll get our export data set and to take a look at what that looks like over here at the end. This is taking a little bit just because we're introducing a model here, and it's going to be training the data and testing the data, and we should get an output pretty soon. And as you can see, we have our original, or our price from our original data. All of our features remain the same, and on the right we've just appended this prediction column, which, as you can see, sort of matches up pretty well with the actual prices or our predictions over here on the right. Now we're going to use these predictions, and rather this trained model that we have now, in the next flow to do some price recommendations for houses that are unpriced and we only know certain things about the features.
So again, this sort of gave you an overview of what you're going to build. Some of the things that sort of you might wonder, okay, so where did the random forest come, and so on and so forth? How do I choose it? So let's see in the next video how you can sort of choose it with clicks in these kind of stuff. Okay, so let me go back again to, so this was an overview, and now we're going to build the step-by-step version of it.
Video, we're going to recreate the price predictions flow. So we want to go up here and click on new flow. And now we want to, let's take a look at our price predictions flow just so we make sure what we're recreating and what we're ultimately doing. So we have input, which is stitched data. We select columns. With one copy, we predict, and then we ultimately join that to our original data and we export out. So that's what we're going to do. Let's go back to our predictions demo flow. Our input is our stitched data. So that's going to be stitched housing data right here. Let's drag that in. Okay, then the next thing we wanted to do was select which columns we wanted to use. So we'll go over here, process data, and we'll scroll to find the select. From there, we made 2 copies of the data, so we're going to process the data. Over here under split, we have copy. Then we're going to, with 1 copy of the data, go over here and predict under machine learning. Let's add that over here. With another copy of the data, we also will then ultimately join with the prediction. So we'll put that over here. And then after we predict, we want to, let's see, come over here to transform, rename columns. And then from rename columns, we'll go to the front of this join right here so that we create a pipeline that looks just like this. And then ultimately we will export that data set. So there's a lot of errors because we haven't specified anything about any of these facets yet. So it doesn't know what model to use, how many copies to make, what columns we're selecting. So let's go ahead and do that. So first let's make sure that our data got imported correctly by peeking it. And it did. We have prices, we have features. That looks great. The next thing we want to do is select which columns we want to look at. So let's go over here, and as you can see, all of our columns are here. We definitely need to look at the price for sure. And then let's also select the same ones as we did in the previous video. So we'll do LSAT, we'll do age, and RM. So let's click update there. Okay, so now we need to specify how many copies we're making. And here we have 2 copies, so we'll update that. Now let's take a look at our predict facet here. So over here we have model name, which we have our Boston Housing RF for random forest. And the version here, we want it to be 2.0. We have multiple versions, but the one that we used in the previous video is 2.0. We could also train a new model here in this case. So either way, but we'll leave it at 2.0 for now. Set our overwrite to be true, and our target column to be MEDV. In fact, let's create a brand new model for this one. We'll see a new model being trained. So we'll update that. Then for rename columns,
so effectively, this is where we made a choice that we're using random forest. There are a few hyperparameters. If you know what they mean, you set it. Otherwise, they're chosen by default. So it's as simple as that.
What we're doing is essentially adding a column, and we'll call it prediction. And since there's no column we're renaming, this will just create a new column called prediction. Then ultimately we are going to join, and we'll just join by rows. once again, we have to specify which side of the table we want this to be on. So we'll say we want our original data on the left and that new column for predictions on the right. And now we should be ready to export our data. We'll call this predictions demo output. Okay, so let's peek right before we export. And if we peek, okay, that ran very quickly. And we have price from original data, the 3 features that we selected, and ultimately the prediction that our random forest model generated. So that's great. We can now run this flow. Just make sure that everything runs correctly.
All right, so at this stage, what we've seen is we've seen 2 things in detail, okay? So we saw how to stage data, and we saw how to sort of make prediction. Forgot to remind you that sort of in your project itself, you will have the data sets already available under data sets. So I will sort of discuss that, but that's that. Now what I want to do is I want to sort of skip this step 3. My hope is that you have access to the platform, you know the videos, all that, you will follow the steps. Let me show you the dashboard, because dashboard might come across very daunting, saying that, okay, so far so good, we're just building these things, but how do I get all of these things together in one place? How does it become an app? Okay, so what I'm going to show you here is a detailed walkthrough. It's a little bit long, but it's really enlightening. It shows a sort of, so you can simply drag and drop and build this massive dashboard, which is an app, very, very quickly. So let's sort of do walkthrough of this. And this will be effectively the last item we will see. And then I want to interact with some of you who have joined here, spending your valuable time. And again, so if there are sort of questions or suggestions, maybe we can go through some of the extra things as well. All right.
We're going to cover how to recreate the Boston Housing Analysis dashboard in the Start Here project. So if we navigate over to dashboards, let's take a look at what we're going to recreate. So as we open the dashboard, the first thing that we see at the top is this nice flow map, which has 4 columns, 4 headers, and shows us what's happening throughout the dashboard. Then we have 4 separate tabs with different data and tables and charts on each of them. And then we have the price recommender tool finally at the end. For a more comprehensive walkthrough of what these different charts and data sets and the price recommendation tool entail and how to use this tool, see the last video. And this one, I'm just going to go over how to recreate this dashboard from scratch. So let's go back to dashboards, hit the plus and create a new dashboard. We're going to want to click interactive and hit submit. So now let's go into this dashboard and begin the process of creating it. So the first thing that we want to do is create that nice flow map that we had at the top. So we hit the pencil to edit the dashboard. Under components, we see process diagram. Now we'll just drag this in, and this blue line shows us where it's going to be dragged in. So we'll drag it in right there. Let's save that. And you can see it's asking us how many columns. So we'll type in 4. And now we'll go in, type in 4. And now we can edit this flow map. So say these text boxes are editable. So we'll say, okay, raw data, stitch data, etc. So these are easily editable, and it's easy to just drag a text box anywhere, and these are also editable. We could do housing prices. It's also easy to change the color. Just hover over this paint and then we can choose any color for the background. And if we wanted to draw an arrow from one box to another, click this arrow, select a target, and we'll click on that one, and now we get an arrow. So not going to completely recreate it, as it's pretty intuitive to set up the text boxes and change the text and whatnot, and set the arrows. So the next aspect of the dashboard was we had our 4 tabs. So before we add in any charts, we're going to just create these tabs so that we have everything at a high level before we start and populate the tabs with the data sets and the charts and the flows. So under components, we'll go to tabs and drag this in right underneath that flow map, and we'll quickly create our tabs. And let's just save that to see what it looks like. So we've got 4 tabs here. Obviously we haven't populated it with any visuals yet. So we'll go back and let's edit our first tab with our raw data. Now, anytime we want to add a data set or a chart that we've already created in the datasets tab, and by inspecting that and adding a chart to that, everything that we've already created is going to be under this charts over here. So we're in components, let's go over to charts. And if you remember, the first thing that we wanted to add was sort of the attributes, the details of what the columns meant in our data set. That's very important and something that we want to see. So we have attributes details data set right here. So let's drag that in right there. As you can see, these are attributes details. If we hover over the right side and just click, we're now able to drag it all the way to the end, and let's save that. So now we have a nice data set here showing us attribute and description.
So effectively, if you have a data set and you want to visualize it or just look at it in the dashboard, it's just as simple as just dragging that name of the data set here. And those names would be effectively auto-populated unless it's some kind of a chart that you might have created beforehand.
For each of our feature columns. So now the next thing that we wanted to add was sort of seeing 2 data sets next to each other in the same block. So let's go over how to do that. We want to add a row right underneath the attributes. And then since we're going to put 2 data sets in this row, we'll add 2 columns. We'll add 1 column and another one. And if we once again hover over this left column, we can drag it over to make it a little bit bigger, as our data set on the left is going to be a little bit bigger and we want to see more of the columns of that one. So let's once again scroll down to charts, and we want housing prices on the right and housing features on the left. So we'll just drag those in and click save. As you can see, all of our data is here. We can scroll down, we can download it as an image or export it as a CSV, and they're visible side by side, features and prices, so we can take a look at what the data looks like before it's stitched. So similarly, now let's go over to the Stitch Data tab and we'll edit it. Very similar to our last tab, we want to now have our stitch data shown. So we will look for our stitch data here. So we have stitched housing data. So let's drag that in right there. And let's drag it across. Once again, we can also add in our description of this stitch data right underneath it. So we can do that really quick. There we go. Let's save that. And well, I forgot to drag this one to the edge. So There we go. And we have our stitch data as well as our description of our stitch data. Very intuitive, very easy to just quickly drag those in and get a nice visual. So now we're going to go over to our predictions and we're going to edit this tab. Now for our predictions, we're just going to want to visualize how well our predictions did compared to the actual prices. So we can drag in our prediction by the LSTAT variable right there. Let's drag that across, and then prediction by rooms as well. And we can drag that across as well. So we'll save that. And now we can see a nice visual of the dark blue is the actual prices and our predicted prices are in light blue. It's a nice visual. We can scroll on the visual as well to see all of the data, and looks like our predictions did pretty well, but also looks like there's no clear correlation between one variable. That's what the distribution kind of tells us here. So finally, we want to use our trained model to create our price recommendation tool. So once again, if you want to know what the recommendation tool does, I highly recommend that you check out the last video in which I explained what it was and how to use it. But essentially, if you remember from that video, the first thing that we want to do is have our unpriced data. Now, one thing about this data set is we don't just want to be able to view it, but we also want to be able to edit that data set. So under components, we're going to add an editable data set. Let's drag that in right here. And then under table type, we want to just do just a single table, and we want that to be our unpriced data right here. So let's now hit generate table component. And as you can see, once we save, this is our unpriced data, and we're now able to edit this. For example, we can delete this row, we could add a new row, we could delete everything.
Effectively here, there's a data set called unpriced data that you're brought in, but now you're able to edit it. So if previously we had uneditable version, now this is an editable version,
etc. So now we're able to edit this data set, and once we hit save changes, that data set will actually get updated. So the goal of this is to be able to update this data set, then run the flow and see what the output is, all from the dashboard. So we want to now run the flow from the dashboard. So as you can imagine, under components here at the very bottom, there's a run flow. So we're going to drag that in. Right there. Let's scroll down to sort of configure this run flow.
Since if you build if you build in APIs, then this effectively is converting your flows into a nice API.
Okay, so for pipeline, as you can see, we have all of the different flows that we've created within this project. So we want to do our price recommender, and we'll give it a nice label, recommend prices. We want to see the log when it succeeds, and we want to set this edit variables to true. And then we'll hit confirm pipeline selection. And once again, just we'll give it a moment here. So now we see which flow we're running, and we were able to run that flow. The last thing we want to do is see the output of that flow. So let's go and add a data set here, which is going to be our recommended prices right there. So let's drag that in as well. Make this a little bit smaller. Drag this across. and drag it down a little bit. And now we'll hit save.
So this flow that sort of, we skipped the construction of it, but there's an instruction and video there. What this flow would do is that take the data from the unpriced value table as input, use the model that we've built effectively as an MLOps, and then sort of produce the output. And that output is saved into this data set, which will be updated once we run the flow, just the way we had seen before. I think in a nutshell, this is a good place to say that we've effectively seen all the construction of the dashboard. There is more information that's there in the video. It's been a pretty long time already. You guys have been listening. So some of you who are building it for you at this stage, it's been a little too much. Some of you who have been simply following, this might look like sort of it's been a little too long. So at this stage, this is a good place for maybe us to take a pause and maybe spend some time interacting if there are questions, concerns, things like that that have come up. Otherwise, would like to sort of just spend some time talking and then maybe concluding. Okay. So again, my hope is that at the end of this, you'll spend some time and build a dashboard like this that allows you to do all sorts of things and effectively build a data app end to end. Let me pause here, stop sharing my screen, and then sort of see if there are questions that you have.